Okay, so the first step on the flow chart is to see if you have a recognizable form. So we have two recognizable forms. You've already learned the geometric series. The next series we're going to learn is the p-series. Okay, so that's your first step when approaching a series, is see if you have a recognizable form. Right, so a p-series has the form 1 over n to the p, and you're going to use it whenever you see something that looks like that. One thing to be careful about is this doesn't work if you have something like n to the p plus 2. You're going to have to use a different tool for that. Okay, so we know that this will converge if p is greater than 1. And it's going to diverge if p is less than or equal to 1. And we learned about that back in section 7.7. We had these integrals for comparison. This is the one we're looking at here. So these series and these integrals are related, so this should look really familiar to you. All right, so let's give this a try. Number 3, so I have 1 plus an eighth plus 1 over 27 plus 1 over 64. So I need to figure out what the pattern is here so I can see if I have a p-series. I know that 8 is 2 cubed, and 27 is 3 cubed. And 125 I know is 5 cubed, and I can make a pretty good guess that 64 is going to be 4 cubed. So this looks like the series from n equals 0 to infinity of 1 over n cubed. Okay, so that is a p-series. I'll write down p-series as my write-up. I know that p is equal to 3, which is greater than 1. So that meets this criteria here. So this is a convergent p-series. P equal to 3 greater than 1. So that's how we would do that right up. And then number 4, so 2 things that I'm adding together. So I'm going to use the linearity property on this one. I have this series n equals 1 to infinity of 1 over n to the 1.4 plus 3 times the series of n equals 1 to infinity of 1 over n to the 1.2. So these both look like p-series to me. Put p-series down, and p is equal to 1.4 here, which is greater than 1, and here p is 1.2, which is greater than 1, so both of these converge. Got that written down, and then I'm going to come back over here and I'm going to say that this converges by linearity. And there you go.